Good morning, ladies and gentlemen. This is Mrs. Avila with your lesson for Thursday, April 30th. So today's essential question is, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? So today we are doing the lesson Energy Entering and Leaving Part 2. So this is lesson 2.1 in Amplify. You do not need to go into Amplify. But we broke this apart into 2 lessons. So yesterday you did part 1, today we're doing part 2. So for today, we're going to watch the Screencastify videos going through the lesson. I'll try to, if needed, I'll break it up into 2 videos so it doesn't take so long to load, but I am having problems with my internet, so it might take a while. We're going to fill out the lesson 2.1 part 2 document. We're going to copy and paste, typo there, paste key concepts numbers 8 and 9 into the Unit 7 key concepts, chapters 2 and 3 document. So you will need to have the Screencastify video open, the lesson 2.1 part 2 document open, and the Unit 7 key concepts, chapters 2 and 3 open. Make sure you press turn in for your lesson 2.1 part 2 document. Do not turn in the key concepts assignment. You will be working on that for several days. The meme of the day, day 25 of lockdown, somebody walks past my house. This is a scene from Toy Story. A stranger from the outside. Ooh, whoa. We're kind of feeling that way at this point of the shutdown, or at least I know I am. All right, so the document that you're first going to need is this one that looks like this. Lesson 2.1, Part 2, Introduction to Energy Entering and Leaving. So the Chapter 2 question, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? Before we get started today, make sure that you have this document open. And that you also have the key concepts, Earth-Changing Climate, that you had open yesterday, open. So today we will run tests in a more complex model, the SIM. We'll see what happens with energy entering and exiting the Earth system when we make specific changes to the SIM. So yesterday in the lesson, you were just imagining what would happen. Thinking about energy entering and exiting a system. Think about that bucket that was part of your warm-up. If you're pouring water in a bucket and the bucket has a hole, what would be happening? And we watched a video that showed energy entering and exiting a system as well. So today we're going to run 3 tests in the SIM, one in which we make no change, one in which we increase either carbon dioxide or methane, and one in which we increase sunlight. Now, before we run the simulation, we're going to make some predictions. Predict what will happen to temperature and energy entering and exiting the Earth system when we make different changes to the SIM. So the first test is going to be no change. I want you to highlight which one you think is correct. So remember, to highlight, you first have to select text. So this here, you are making a prediction. If you make no changes to the system, the temperature will increase, decrease, or stay the same. So if you think it's going to increase, you're going to highlight that. You're going to come to these 3 dots right here, click on that. This is the highlighter, and you would highlight increase. Okay. So you're going to make a prediction. If we make no changes, what will happen to the temperature? Now predict what will happen to the amount of energy entering and exiting if there were no changes. Do you think more energy will enter than exit the system? Less energy will enter than exit the system? Or the amount of energy entering and exiting will be equal? So again, if you want to highlight A or B or C, you select the text, you press on the 3 dots, and then you click whichever color you want to highlight it, okay? All right, you're going to make some predictions about test 2. Increase carbon dioxide or methane to 550 parts per million. Highlight which one you predict is correct. Remember that when you're predicting in science, it's okay if your answer doesn't turn out correct. It's just making you think about the material before we actually do it. So it's okay if your prediction it turns out not to be correct. We still learn from that. So here, this is increasing carbon dioxide or methane. Choose which test you're going to watch. I'm going to have to run both of them for you guys. But let's say that you want to focus on carbon dioxide. You're first going to highlight carbon dioxide. If you increase carbon dioxide, temperature will, what do you think it's going to do? Do you think it's going to decrease? Then you're going to highlight that and choose your color to highlight that, okay? If you don't want to focus on carbon dioxide, maybe you want to focus on methane, choose methane, and then decide what you think is going to happen when we increase methane, all right? But you're making your predictions here. Predict what will happen to the amount of energy entering or exiting the system. A, more energy will enter than exit. B, less energy will enter than exit. Or C, the amount of energy entering and exiting will be equal. Whichever one you think is correct, you're going to highlight. You're going to highlight a choice here, okay? All right, test number 3 is if we increase the sunlight. Highlight which one you predict is correct. If you increase sunlight, temperature will A, increase, B, decrease, or C, stay the same. So highlight which one you think is correct. I'm taking it off just so I'm not trying to influence anyone's answers. Okay, next one, predict what will happen to the amount of energy entering and exiting. And we're talking about Earth system. And we're talking about when we increase the sunlight. A, more energy will enter than exit. B, less energy will enter than exit. Or C, the amount of energy entering and exit will be equal. Okay, so highlight whichever one you think. I'm just randomly picking right now. All right, so we're ready to move on to part 2, testing changes in the sim. Teacher will run the sim in the video. You're watching the video right now. We're going to run the sim until the timer reaches 20 seconds before pausing to make a change so we can see like before and after. We're going to make only one change per test. Test number 1 will be no change. Test number 2 will be increasing carbon dioxide or methane to 500 or 550 parts per million. Test 3 will be increasing sunlight. When the timer reaches 40, we're going to observe the temperature, the energy entering, and the energy exiting. All right, so I'm going to go into this. Here is my sim. I am in Earth system mode. Again, ladies and gentlemen, you do not need to go into Amplify. I'm going to let this play for 20 seconds. All right, I pause it. I'm going to, this is make no change, so I'm going to continue. And I want to point out energy entered and energy exited are up here. And you'll see that the numbers stay pretty close together. So energy entered was 272. Energy that exited was 272. So going to our document, the no change test, once the sim is done running, highlight which one is correct based upon the sim. So when you make changes in the sim, temperature, and actually here it would be, when you made no changes in the sim, temperature, what did it do? Let's look at temperature. Temperature actually stayed the same. So the temperature stayed the same. I'm going to highlight that. What did you observe about the amount of energy that entered and exited? That was these numbers here. More energy entered than exited? No. Less energy entered than exited? No. The amount of energy that entered and exited was equal. They were. Even if it was a little tiny bit off, a few digits difference, a few numbers, 1, 2, 3, that would be still pretty stable. So we're going to say that the amount of energy that entered and exited was equal. Okay, so now we're going to test increasing carbon dioxide or methane to 500. So I'm going to go back into my sim. You guys do not need to. Okay, I'm going to press play and let it run for 20 seconds. So we have a before. Okay, temperature 13.7, 13.8. Pause. Now I'm going to increase carbon dioxide first. All right, I'm going to let this play. Let's see. Energy entered. So far seems, oh, I'm starting to see an increase. Energy entered has definitely increased. I'm going to pause it here. Energy entered was 276. Energy exited was 260. You will notice that the global average temperature actually increased. In our last test, it was like 14.7 degrees Celsius. Now it's 20.1. We had more energy entering the system than what was able to leave the system. So therefore, that energy builds up and it warms up the earth. So we go back to our document. When we increased, I'm going to say carbon dioxide. If you want to wait for methane, that's fine. When we increased carbon dioxide, the temperature increased. What did you observe about the amount of energy that entered and exited? When we increased the carbon dioxide, we saw that more energy entered than exited the system. This number was bigger than this number. It was imbalanced. There was more energy building up there. So more energy entered than exited. Right, I'm going to run the sim again, but this time I'm going to do methane. Methane is another type of gas, greenhouse gas. Let it play until 20 seconds. A big contributor to methane in our environment is actually cattle. Cattle's poop and has a lot of methane in it. And cows actually fart, and they fart out methane. You guys are probably laughing right now, but it's true. Even when you fart, sometimes you let out methane. But cattle are big contributors to increased methane levels because there's been a higher demand for cattle. So a lot more cows on Earth. Think about how much beef is consumed whenever you go to McDonald's, Burger King, any of those burger joints, that relies on cattle. And so there's been an increased demand for cattle, more cattle on Earth that are resulting in more methane in the atmosphere. So I've increased methane. I'm going to let it play now. Okay, looking at temperature, temperature is increasing. Energy entering the system is higher than the energy that is exiting the system. So I pause it here. I let it go about 1 second longer than the other ones. But the temperature, 20.1 degrees Celsius, energy entered, 278 amount of energy entered, 278, compared to 254, I believe that is. I might have to let that play a second. Yeah, 254. So going back to this, for methane, if you wanted to record methane, you would highlight methane. but our answers would be the same. The temperature increased and more energy entered the system than exited. Okay, so it doesn't really matter if you were looking at carbon dioxide or methane, the results were the same. Okay, so now we're going to test sunlight. So I'm going to reset this. Yes. And I'm going to let this play for about 20 seconds. Okay, so global average temperature is about 14.3. Right now, energy entered and exited are equal, but now I'm going to increase sunlight. I'm going to increase sunlight to high. I'm going to let this play. You're still thinking about cows farting, huh? All right, so I pause it and let's look at it. So the global average temperature increased. Energy entered 323, energy exited 288. So here the energy that entered the system was higher than the amount of energy that exited the system. So going back to our document, when we increased sunlight, the temperature increased. What's the wrong one? What did we observe about the amount of energy that entered and exited? More energy entered than exited. So what happened in each of the sim runs? When we were testing no change, energy entering is equal to the energy exiting. When we increased carbon dioxide, more energy entered than exited. When we increased methane, more energy entered than exited. When we increased sunlight, more energy entered than exited. I'm going to pause this for a second. Okay, I was trying to decide if I was going to do a second video, but we're almost done, so I'm just going to continue with this one. All right, so we have a claim here. In the case of no change, the system is stable. Even though energy is moving around a lot, the amount entered is balanced by the amount leaving, and the temperature stays the same. When you increase carbon dioxide or methane, the system is not stable, so temperature changes and the amount of ice can therefore change. So here we get to key concept number 8. So just like you did yesterday, all you're going to have to do is you are going to copy key concept number 8. You right click, you press copy. I didn't open my key concepts page. You go into your key concepts page, your document that you are pasting these in, and you go paste key concept number 8 right below number 6 and 7 that you did yesterday. So key concept number 8 is that temperature increases if more energy enters a system than exits a system. All right, and then Ms. Schumann put some diagrams here to help you think of it. What this is more energy entering a system than exited, then the temperature would increase. In the investigations you did in the sim, you investigated some scenarios where Earth was getting warmer and observed the differences between energy entering and exiting. Now you need to apply what you learned to a different situation, a time when Earth is getting colder. Between the years of 1200 and 1600, global average temperature decreased. Which do you think is true about the energy that entered and exited the Earth system during this time? A, more energy entered than exited. B, less energy entered than exited. Or C, the same amount of energy entered as exited. So I think we forgot to put highlight here, but you're going to highlight whichever one you think is correct. Between the years of 1200 and 1600, global average temperature decreased. Which do you think is true about the energy that entered and exited the Earth system during this time? Do you think more energy entered than exited? No, it would be warming up at that point. Do you think less energy entered than exited? Maybe. Do you think the same amount of energy entered as exited? No, because that would be a stable environment and the temperature would stay the same. So the best choice is going to be B. Less energy entered the system than exited. So energy was actually leaving the system faster than it could come in. So this leads us to key concept number 9. Temperature decreases if less energy enters than exits. And that should be than. So less energy, temperature decreases if less energy enters than exits. So this is a key concept. It's in orange. You're going to copy by right-clicking, copy. You're going to go to the key concepts document, and you're going to paste that on there. Okay. All right, that's it for today's lesson. Please turn this assignment in when you are done. However, do not turn in the key concepts assignment yet. You will continue to work on this through chapters 2 and chapter 3. So do not turn in the key concepts, but do turn in this one. All right. Hope you have a good day and stay well, stay healthy. Bye-bye.